So today's seminar is on types of data and statistics and the importance of data in healthcare quality improvement. What is data? We have been using this term data. It's so familiar to us. In our day-to-day life, we tend to use this term in many instances. In statistics, data simply means plain facts. It's unstructured information, usually raw numbers or facts with no meaningful description. So data simply means raw information. The information something collected without any meaning or description. In healthcare, data simply means information collected about a patient, family, or a community. So many of the acknowledged persons have talked about the significance of data. Let's see a few. He is William Edwards Deming. He is an acknowledged statistician and a management thinker and a quality analyst. According to him, data. Without data, you are just another person with an opinion. He even went on to the extent of saying, just one moment, in God we trust, all others bring data. This is the importance of data according to William Edwards Deming. And Tim Berners-Lee. He is a computer scientist and he is best known as the inventor of the World Wide Web. According to him, data is a precious thing and it will last longer than the systems themselves.
Medical certificate है CPHC certificate for health
quality. So we have seen about the definition of data and what data exactly is. Now, why do we need to collect data? What is the purpose of data collection? Why is there so much fuss about data collection? See, according to William Edwards Deming, the ultimate purpose of collecting the data is to provide a basis for action or recommendation. So coming on to the types of data. Data is primarily classified into two types, quantitative and qualitative. Quantitative data is further subclassified as discrete and continuous, whereas qualitative data is subclassified into nominal and ordinal data. Am I clear till now? So this is the basic classification of data in statistics. So let's discuss about quantitative data in detail. What is quantitative data? It simply means the data that can be quantified. Data in the form of counts or numbers, numerical in nature. Here, each data set has a unique numerical value associated with it. Quantitative data can be counted or measured and eventually given a numerical value. It is structured in nature, it is factual, and is most suitable for statistical analysis. And quantitative data is used to answer questions such as how many, how often, how much. These type of questions will always give you an answer which provides us with a quantitative data. Some of the examples for quantitative variables, it includes age. See, when a person is questioned about his age, he always gives an answer in a numerical value. He may say, I'm 25-year-old, I'll be turning 60 this year. So the answer, the output you get is numerical, it is factual. Accordingly, the number of weeks, the number of days in a week, or the number of days taken to complete a work, it always gives you a numerical answer. You always tend to get a numerical answer. Similarly, the length and distance. Here, the length and distance both can be measured and expressed in a numerical form. So as I said earlier, quantitative data is further subclassified as discrete and continuous. Let's discuss about discrete data now. So discrete data, it primarily means count data. That is the data that is collected by means of counting. It can take only certain numerical values. More specifically, to be very precise, discrete data can take up only whole numbers. Only then it will give you a meaning. It is a fixed value and cannot be further broken down. Some of the examples for discrete variables. First, the number of children. These are very basic examples I'm talking about. Number of children in a family. It can either be 1 or 2, or sometimes there can be 10 children in a family. You can never express the number of children as 1.5, 2.5. So it can take only certain numerical value. To be very precise, it is always a whole number. And next, the number of employees in an organization. It can range anywhere between 100, 1,000, depending on the organizational type. And the example, current example is the number of participants in this webinar. Number of participants attending this webinar is currently 22. See, it's a whole number. It cannot be broken down. 22 is always a 22. It's universal too. And number of physician visits in a year. A patient can visit his physician once or twice, depending on his health status. It is always expressed in a whole number form. Now moving on to continuous data. Continuous data is again a type of quantitative data which can be measured. Any physical quantity that can be measured, it tends to be a continuous data. It can take any value. It is not fixed to one. It is not a fixed value. It can take both whole and fractional numbers. In either ways, you'll get a meaningful value. And this data can be broken down infinitely. Few examples for continuous variables: the height and weight of a person. The height and weight can be measured, and it can be either expressed in a whole number form or in a fractional form. For example, if you measure a person's weight on a digital weighing scale, you tend to get a fractional value or a decimal value, 59.65. If you're getting a value, similar value, you can also round it off to the closest numerical whole number value, or you can simply say it as 60 kilograms. In either ways, you get a meaningful value. Similarly, blood pressure. Blood pressure is a parameter that is measured using an instrument, and because of the limitation of accuracy, it is always expressed in a whole number format. But blood pressure is always a continuous variable. Likewise, temperature. Normal body temperature of a human being is 98.4 degree Fahrenheit. It can be rounded off to the closest whole number value. Similarly, the boiling point of water, 100 degrees Celsius. It can either be 100.1, 100.2. In any ways, it will give you a meaningful value at the end. So I hope quantitative data, the points and the types of quantitative data is quite clear to you. Now, moving on to the second type of data we use in statistics, that is qualitative data. Qualitative data is defined as the data that approximates or characterizes. So it is non-numerical in nature. In statistics, we also call it as categorical data. That is, this data can be arranged categorically, or it can be categorized into different groups based on the attributes or the quality and properties of a thing or a phenomenon. Qualitative data is always descriptive in nature. It is a subjective feeling. It cannot be expressed in numerical value. It can be expressed only in terms of language. So qualitative data can be observed and collected. For example, when you see a cake, you first notice the color. You first observe the color of the cake. The cake can be orange in color. The cake can be white or brown, depending on the flavor. So we simply observe the quality, the color. So this comes under a qualitative data. Likewise, the color of hair in females. Not every female will have the same type of hair texture or hair color. They tend to have brown, black, blonde, and red. So it simply defines the quality or the attribute of a woman. Now, how to collect qualitative data? Because I said it is more descriptive in nature, open-ended questions primarily provide qualitative data. What are open-ended questions? Open-ended questions simply yes or no type of questions. For example, if you want to ask a person, do you belong here? Is your native place Chennai? He'll say yes or no. It's depending on us. We can further probe the person. So, what is your country of origin? So, what is your native? What is your place of birth? So, this comes under the second category, closed-ended questions. You can ask a person, what is your mother tongue? He can say either Tamil, Telugu, Kannada, Malayalam. And what is your highest level of education? A person can be an illiterate, or he could have been a master's or a doctorate. And questionnaires and surveys always most often provide us with the qualitative data. Let's discuss more about qualitative data. So some of the best examples for qualitative variables for better understanding. The color of the eyes, it simply defines the quality, a person's attribute, and smoking history. By posing an open-ended question, yes or no type of question, you will get an answer for the smoking history of a person. Similarly, the happiness rating scale, the state of mind can be only expressed, can only be described. It cannot take any numerical value. A person can be depressed or a person can be unhappy or neutral. So this primarily comes under a qualitative variable. Qualitative variable is further subclassified as nominal and ordinal. Let's see about nominal data first. Nominal data is primarily attribute. It's all about the attributes or the qualities of a thing or a person or a phenomenon. The range of values you get from the nominal data is not ordered in any sense. It's just simply named. See, for better understanding, gender. A person can be either male or female. So it is just a category. It is not arranged or ordered. It is not ordered according to a scale or a grade. Similarly, blood groups. There are 4 major blood group types, A, B, O, and AB, depending on the antigen present. So it's just grouped according to the presence of antigens. And marital status, single. A person can be single or it can be married, he's divorced, he's widowed or divorced. It has nothing. It is not graded or it is not given a scale or a rating. It's just grouped. That's it. Then coming to ordinal data, as the name suggests, it is ordered. It is categorized in a certain order or on a scale. It has a natural ordering or it has a grading or rating. Coming to the examples for ordinal variables. The severity of disease. The severity of disease can be graded mild, moderate, or severe depending on the presenting symptoms. So there is a grading depending on the presenting symptoms. Similarly, the pain scale, the pain assessment tool is graded from 0 to 10. And a score of 1 to 3 means the person is experiencing mild pain. And if a score of 10, it means the person is experiencing the worst pain possible. And coming to customer satisfaction surveys, a customer can rate his experience depending on the service or depending on the quality of the product. He can grade it anywhere between poor to excellent. So this is graded depending on the experience of the customer. Now we have discussed the types of data. We'll see in a nutshell, we see the difference between quantitative and qualitative data. So it's just the recap of the previous content. Quantitative data is numerical data. It's countable or measurable, whereas qualitative data is categorical data, more of descriptive in nature. It's relating to words and language. And quantitative data tell us how many, how much, or how often. Through these questions, we always tend to get a quantitative data, whereas qualitative data, it always describes the attributes or qualities, and it helps us to understand the why or how behind certain behaviors. Quantitative data is fixed and universal. In fact, it is factual, whereas qualitative data is dynamic and subjective, open to interpretation. It all depends upon the subject's way of interpretation. Quantitative data is gathered by measuring and counting things, whereas qualitative data is gathered through observations and interviews. Quantitative data, because it is numerical in nature, it can easily be analyzed using statistical analysis or tools. Whereas qualitative data, because it is more of descriptive, it has to be analyzed by grouping the data into meaningful themes or categories. Both the types of data, quantitative and qualitative, has its own advantages and disadvantages. First, let us see about the advantages and disadvantages of quantitative data. The first and prime advantage is it is relatively quick and easy to collect. Hence, a larger sample size can be collected. When conducting a survey, it is always better to collect a larger sample size to get reliable conclusions. And quantitative data is also less susceptible to bias when using random sampling method. So random sampling method is that every unit of the population has an equal chance of getting selected. So you can draw reliable conclusion. So it is more representative of the population. And quantitative data, because it is numerical in nature, it is suitable for statistical analysis and can be analyzed using mathematical rules and principles. And some of the prime disadvantages of quantitative data, it includes it lacks context, and there is risk of bias when using questionnaires or surveys. Questionnaires and or surveys, it is one of the methods for collecting data. So I'll discuss about it in the next slide. Why did I say quantitative data can lack context? The best example is if a person is conducting a questionnaire to feel how customers are feeling about a new product, the quantitative data will only give you the proportion of the customers who are really happy or who are unhappy with the product. But it won't tell you the reason why. You can't get the reason why the customer is unhappy. You will only get a numerical value, how many percentage of the customers are happy or how many percentage of the customers are unhappy. Sometimes you'll need to delve deeper to gain valuable insights beyond the numbers. And I told you there's a risk of bias when using surveys and questionnaires. So while using surveys and questionnaires, the researcher, he has to devise it carefully. The questions are worded, and the way in which the questions are worded can allow researcher bias to seep in. So it's always important to make sure that surveys are devised carefully to avoid bias when it comes to quantitative data. Qualitative data, it has its own advantages and disadvantages. First thing is it helps in in-depth analysis because you not only get the data alone, but you can probe the subject. You can still probe the subject. Why? How? Anything you can probe to get more information. It provides the researchers with a detailed analysis of subject matters. It offers rich, in-depth insights and allows you to explore context. So this is great for exploratory purpose. Most often, we always use open-ended questions for qualitative data. So the subjects or the respondents are free to express their opinion. So we can get more information. We can extract more information. So it can always provide you with rich data. Qualitative data can always provide you with rich data and with insights. But the disadvantages are it is time consuming. Only a smaller sample size can be included. Because smaller sample size is included, it is not easy to generalize with the population. This is not a good quality of data. The sample collected should be representative of the population. Finally, it depends on the researcher's skills. It all depends on the researcher's skills, how to formalize the questionnaire or survey, or how to probe to extract more information from the samples or subjects. This is a very simple illustration to show the difference between the different types of data we discussed earlier. So see the first picture, the first two pictures, it denotes quantitative data. Third and fourth, it denotes qualitative data. So the first picture, it shows the count of the apples, the number of apples. There are about 10 apples in the picture. So 10, you're counting it. So this easily becomes a discrete data. But if you're going to a shop, you're going to get a 1 kilogram of apple or 2 kilograms of apple. The apples are going to be weighed on a scale, on a measuring, on a weighing scale. You can get any value. It can range 2 kilograms or 2.5 kilograms. So this becomes a continuous data. Third picture, the apples are grouped or categorized according to the color. Red delicious, Granny Smith apple, golden delicious, yellow. So it is based on a quality, the apples are categorized. So this becomes nominal data. And the last picture, the apple is graded according to its size, small, medium, and large. So this easily becomes an ordinal data. I hope this gives a better understanding for the different types of data so you can apply it in our day-to-day situations. Now, we have discussed about all the types of data. Now, we need to assess which type of data is more powerful in statistical point of view. It is always the continuous data. Why? Because it is continuous. All mathematical operations can be performed and more statistical tools are available for analysis. And whenever possible, a researcher or a statistician should prefer collecting continuous data. Now, the first step is over. We have collected the data needed, but the data alone is not going to be helpful in any way. This data has to be converted into something meaningful. That is the information. This is a very prime step. This is a very prime step, and this is where statistics comes into play. She is Carly Fiorina. She is the ex-CEO of Hewlett Packard. According to her, the goal is to turn data into information and information into insight. And Daniel Keys Moran, he is an American programmer. He has said, you can have data without information, but you cannot have information without data. This is very, very true. Without data, you can never have the information you wanted. And according to this, data are just thousands of stories. Tell a few of those stories to help make the data meaningful. So data has to be converted to a meaningful information. How to convert data into information? Here are a few tips. Data collection is a very important step, and even the quality of data matters. First, you have to collect only the data that is accurate and relevant. The accuracy and the relevance of data plays an integral part in assessing the information we want. And you should employ tools that help you to analyze data. And finally, the data collected has to be transformed into valid information. So, as I said, statistics. What exactly is statistics? It is a tool for converting raw data into meaningful information. This is a step-by-step process how data plays a major role in formulating an action plan and to improve our process outcome or improve the quality. Data is the evidence for preparing action plan. How? The collected data has to be analyzed using the statistical tools or methods. Through analysis, the data is converted into a meaningful information. Through this information, the data can be visualized as tables and graphs. Then with the information we have gathered, we need to come up with the action plan. Accordingly, we can adjust our process outcome or we can work towards our objective. This is the basic model for the processing of data. how it is transformed into wisdom, how it is helpful in making decisions. This is called the data information knowledge wisdom model, also known as DIKW pyramid. As you can see, it is structured as a pyramid. Each step up the pyramid answers questions about and add values about the initial data. See, data, it forms the base of the pyramid. It is just raw. It has no meaning. It knows nothing. It is just a collection of observations or facts or raw facts. Then the data is converted into information. Information is processed into knowledge, and through the knowledge gain, we have to apply our wisdom in making in real life situations, in making decisions. As I said earlier, data, it's just facts or figures. It knows nothing. When given context, it becomes information. Information, when given meaning, it becomes knowledge. And knowledge, when given insight, it becomes wisdom. Through the wisdom gained, we can improve the process outcome. So this slide is self-explanatory. What is data? As I said earlier, data is just observations or measurements of phenomena in the natural world, whereas information is structured data. It shows a pattern or framed in a context relevant to people. What is knowledge? Knowledge is information that has been organized and interpreted. See, according to the knowledge gain, we have to act on the information. And finally, the wisdom, knowing when and how to act on that knowledge to achieve desired goals. So this is the DIKW pyramid or the model. And this clearly explains how data forms the basis for formulating an action plan. Now moving on to healthcare analytics. Healthcare analytics is the process of analyzing current and historical industry data to predict trends, improve outreach, and even manage the spread of diseases. As I said earlier, data can be analyzed manually with the help of statistical tools or with the help of software and algorithms. Then the analyzed data has to be visualized by tables or graphs or charts. It can be useful for designing presentations and showing trends. All in Ultimately, it can reveal paths to improvement in patient care quality, clinical data, diagnosis, and business management. What is healthcare data management? We have collected ample data from different sources, but our aim is to store, protect, and analyze the data pulled from diverse sources. Healthcare industry is data rich but information deprived because not all data collected is converted into information. We just collect data. We have to manage the wealth of available healthcare data. This allows health systems to create holistic views of patients, personalized treatments, improve communication, and enhance health outcomes. So, what are the advantages of healthcare data management? In the current scenario, we have advanced healthcare data management systems. It reduces operational cost, it reduces patient cost. Patient won't be paying much, thereby, you can improve the patient turnover. You can even make better business decisions with proper healthcare data management. And coming on to the conclusion, I've talked enough about the data, the types of data and statistics. So ultimately, I would like to say better data means better medical care. Having the right data in a timely manner simply enables better healthcare if you can productively harness the data. The data collected has to be converted into meaningful information and decision making. This is called the data driven approach. Decision making should be based on facts, regardless of industry, be it business or health. The importance of data collection and its analysis has demonstrated the more accurate the information gathered, the sounder the decisions made, and better the results that can be achieved. This is the ultimate goal for healthcare quality improvement. No matter whatever technologies we have, it all depends on data. It all depends on the patient data. So always tend to collect better data to ensure better medical care. Thank you so much for your time and attention. And thank you, Dr. Tennarasu, for this opportunity. And if you have any clarifications or questions, please go on. Hello.
Hello, good evening. This is not about the questions, but I want to express.
Hello.
Hello, can you hear my voice?
Yeah. Now you're audible.
Yeah. No, this is just a very sublime presentation. Amazing. The slides are
Thank
very
you.
nice and understandable, especially that Apple, that what you are
Thank you so much.
differentiate that the data really wonderful. Thank you
Thank you
so
so
much.
much. Thank you so much.
Because of your nice presentation, I don't have any queries to ask. Thank you so
Thank
much.
you, sir. Thank you, sir.
Thank you, Dr. Meera, ma'am.
Thank you, sir. Thanks a lot, sir.
Nice presentation.
I hope
I learned
this.
many things.
Thank you so much, sir.
So, as per the current scenario,
Yes, sir.
even we can draw one graph for the relationship between understanding data and availability of data. Even we can share one graph, like, as per the current scenario, the availability of data is increasing exponentially, correct?
Yes, sir.
But what about the understanding of data from our side? It is constant.
Yes, sir. Absolutely.
This is about understanding of data, and this is about the availability of data. So especially as per the current scenario, we can able to collect many data in healthcare system. Even after EMR, we can collect many data, correct?
Yes, sir.
But what about the understanding of data? How many people are converting data into information? And what about our decision-making process, whether it is based on our data? So why still there is no awareness about data? What do you think, doctor? Why still there is no awareness about data-driven culture? Many people not aware about data-driven culture. There is no importance, data just we can cook. Just we can prepare something and we can show in front of JC or any beach people. But why still there is no awareness about data-driven culture? What do you think?
Because people don't know the importance of data, sir. So even if you visit a hospital for a simple consultation, we tend to provide a lot of information, but they just collect it and store it. Nothing has been converted into a meaningful information, or nothing has been done.
But what is the purpose of EMR, ma'am? What is the purpose of EMR? Is it to collect only data?
Only for patient identity. No, sir. Electronic medical records, it's just for the easy identification of patients according to the hospitals.
Oh, can I intervene? It's a open discussion. Can we take like that?
Sure,
yes,
sure.
Sir, yes, sir. Yes,
sure,
sir. Yes, sir. Please go ahead.
Yeah. Say EMR is not only for, it has that many advantages. So the people can have that, multiple number of people can have a single record at a time. So, so in that also that, and we can get lot of informations. Even I can say that even that what is that availability data and understanding of data also now slowly increasing. Maybe it's not increased as much as the availability of data.
Yeah,
but now
because there is significant gap, sir. There is increase in understanding of data also, but still there is significant gap between the availability of data and understanding data.
Yes. Agree that.
Yes.
Sir, may I add a few lines, sir?
Yeah,
Dr.
please.
Jaswant Tarneja from Delhi. Data-driven culture is very important for development, because I have observed that if you compare, say, few eye hospitals, I am an eye surgeon by profession. If you compare few hospitals who claim that they have a good quality, And if you ask them, what are the indicators, what are the criteria for that? And if you compare, say, for example, number of surgeries done in a hospital, if you make a chart or if you show in a diagram depicting the number of operations done in hospital A, hospital B, hospital C, you compare them and you present it in the to the knowledge of public. Number one. Number two, outcome of operations. So many patients were operated and so many patients were satisfied. This is the data in hospital A, in hospital B, in hospital C. Number three, similarly, patient satisfaction, comparing hospital A, hospital B, hospital D. Similarly, patients' cost of operation. If this is made public, people will come to know more about the culture of data development. This is going to be very helpful in future. This is going to be very, very helpful in future. And I feel if we are taught, this is just the theoretical knowledge which is given to us. But if you talk to us in a practical situation, say for example, any hospital, if you take the data, what are the data there, and where all you can develop, where all you can develop, that will be more helpful. If we learn this, then we can propagate it further. We can propagate it further.
We'll do more webinar from our real scenarios, sir. Don't worry, sir.
Yes, that is a practical approach, and that will be very helpful. We will definitely help to develop this culture and exaggerate it to the public, to the general doctors also. We can create some assessment webinar meetings, say for a meeting of eye surgeons, to develop data, so that this is possible only if we show and if we compare the two or three hospitals, then each will come out ahead to show that he is better. Because many eye centers are having multiple branches. So they claim that they are bigger, while a single center, he may be better, but because it is small and he doesn't have data, so it is not comparable to others. So this development of data culture, I am repeating again, is very useful. And I really appreciate Dr. Thana, sir. It is very important. I'm very interested in the subject, but please bring it practical information, sir.
Thank you. Sure, doctor. We'll do. We'll explore many real scenarios. Don't worry.
Thank you, sir. Thank
you. Now there is huge demand for data analytics, especially in abroad. There is huge demand for data analytics. If you are going to collect some data and if you are going to do some data analysis, what is the first thing we need to check? The data type. But if you search in Google, even in YouTube, still there is no clear idea about different type of data. There are a lot of misuse. Still many people not aware about the difference between nominal data and discrete data, attribute data. So if there is no clear idea about type of data, then how can we do analysis? How can we use some statistical software for analysis? Even if you're going to use SPSS or SAS or R, without understanding the type of data, how can we choose the tool in the statistical software? So this is the problem. This is actually basic, but it's very important. Even the graph, statistical tool, everything depends on the type of data. So we can choose separate tool for each type of data. If it is continuous, yes, we can use this tool. For discrete, we can use some other tool. So this is very important. And there are a lot of examples from Dr. Meera presentations. But if you include some real scenario, probably we can able to get more informations.
Okay.
Yes. Any other comments from others? Any questions for any comments for opportunity for improvement?
Sir,
this is just a learning stage. We are in learning stage, correct?
Yeah.
Yes,
sir, I'm
yes,
Jansi from Bahrain.
Yes, ma'am.
Your student. Actually, I'm this data reliability and validity, like especially when we use a tool. How do we do that in practical scenario? Next time, if you can touch, it will be very beneficial for us, sir. Because now we have improved, at least after this classes and all. Now we know at least appropriate graphs.
So there is significant improvement after your CPHU, correct? There is improvement after CPHU.
100%, sir, 100%. I'm able to apply a lot now. But I have weaknesses also, and one is this reliability and validity. Theoretically, I know. Yeah, theoretically we know, but practically how to do that in a clinical setup. If
Sure,
you can
ma'am.
teach us that, I'll be very grateful to you. Sir.
Exactly. Sure, sure. We'll do, ma'am. We'll do a separate webinar for this.
Thank you.
Sir,
Thank
I
you.
want to add few lines, sir.
Yes,
Permit
sir.
me.
Yeah, yeah, please. Please go ahead.
Sir, I am a NABH assessor also. I am assessor of NABH and course, and I have assessed many hospitals.
Excellent.
Sir, one thing I feel we are lacking is the data assessment. So if you are trained a little more about the Excel and Minitab and practical training in a hospital, if
Yes,
this is
yes.
done practically in a hospital, we are
Yes.
shown their data and we are shown how to reevaluate, assess, and then present.
Yeah,
Then that will
exactly.
be very helpful. That we
Sure,
can.
sure.
This will really be very practical and useful for quality improvement of all the processes and outcomes.
Sure, sure, Doctor. Will do. Thank you. Thank you, Doctor. Thanks for your comments. These are all opportunity for improvement. Yes. Any other comments from others? Yes, Dr. Meera, ma'am, anything you want to share?
No, no, sir. I hope everyone had a clear understanding.
Yes, ma'am, 100%. There is no doubt. Yes, Dr. Reshma, ma'am, any question?
No, no question. First of all, Meera, it was a wonderful presentation.
Thank you,
So-
Dr. Reshma.
We got a real brush up again, a refresher to our CPHQ. One thing is there that what Dr. Neja was also saying, sir, and I think Jansi said, data validation is again a big question to all of us.
Sure.
In spite of being yes, assessors or in spite of, being in the system for quite some time, still when it comes to validation, like when we are assessors, when we go, people only show us bar
Yes,
control
yes,
chart
yes.
still.
Yes, yes. We don't know
Uh,
the quality
yeah.
of the data.
In India, there is a huge opportunity to develop this, and I think we should encash on this on behalf of our forum that
Sure,
we
sure,
should have more regular webinars, and all of us should try and bring more audience to this because.
Yep.
Because then only people will understand. Otherwise, still everybody knows that okay, bar chart is fine, and they are
Yeah,
happy
yeah.
in the red and green bar charts. So that is it. So opportunity for us as a forum
Exactly,
to
ma'am.
much more webinars. I think we should have. Each one of us should try and bring more audience to this. Then
Yes.
only there'll be some awareness. Currently, now for the name of NABH, now we are preparing graphs and showing.
Yes.
But actually, I don't know how much as assessors also people would really understand. So when they don't understand, they won't even ask questions, no? So it's all fine when the
Yes.
graphs are shown.
Yes.
So validation, though it is a standard in NABH, but I don't know how people are doing. Some validation is happening. So validation, sir, we should have a webinar, maybe
Sure,
in
ma'am.
future.
Will do. Will do, ma'am. Will do.
Indicators you can take, some clinical indicator, some operational indicator, and
Yes.
just we the exercise of how to validate that particular one or two.
Exactly.
Yes,
Sure, sure. Sure, sure, doctor.
That's what is from my side.
Thank you. Thank you, doctor.
Yes.
Thanks for your comments. We'll do more webinar, even for data validation, even for some indicators. What are the indicators we can use to assess nursing service? What are the indicators we can use to assess radiology service? So we'll do more webinar for the real scenario. Okay. Yes, Dr. Meera, thanks a lot for your continuous support, for your presentations.
Thank you, sir.
Thank you all.